This is 8.3, 3, graphing quadratic functions. All right, here are 3 forms of the quadratic function. This one we're familiar with, ax squared plus bx plus c. Remember where a, b, and c are just numbers. They stand in for numbers, and they shift the graph and move it around, or shrink it or open it. This is called standard form. Now this is, you should, I maybe should have said this way earlier, but you should be looking at the Penn Foster as you're watching these videos. You should write this down: standard form, vertex form, and factored form. These are the 3 main forms of the quadratic equation, and they give you different bits of information. So this is the standard form, and it's just the fully written out, gives you all the variables, and you can just graph with putting in x. You put in 0 for x, see where it goes. Put in 1 for x, see where it goes. Put in -1 for x, see where it goes, and just graph it out. But these other ones give you certain bits of information. So this one is called the vertex form. A times x minus h squared plus k, where h and k are the x and y of the vertex. Like that. HK gives you the vertex, which, if you'll remember, was the point at the bottom of the graph. So for instance, if you had f of x equals 2x minus 3 squared plus 4, if they gave you this, then you would take that 3, ignore the negative because the negative is part of the equation. See, the negative is part of the equation. Take that 3, take that 4, move them down, 3, 4, and your vertex is at 3, 4. So that one gives you your vertex. Okay? This other one is a times x minus p times x minus 9. Now, if you recognize this as a binomial, then you'll see that when we were solving for zeros earlier, where they would give us a number, we would have like x plus 3 times x plus 2, right? And then the answer would be the opposite symbol, opposite negative or positive of these answers, because we would set them equal to 0, move this across the equals to the 0, and so the x would equal -3, or well, and -2. That's what this one is stating. It's just stating it as a rule, so that whatever your number is, you take the opposite sign of it. That's right. Opposite sign of it, and that gives you the answer for where the x-intercepts are. Okay. Here is example number 1. They give us f of x equals 2 times x minus 2 squared plus 3. Now, if you look back, you'll recognize that this is in vertex form. A times x minus h squared plus k. See that? That's vertex form. So the first thing we're going to do, anytime we see it in this form, is just take that 2 out, take that 3 out, put them to the side. That is our vertex. We might need that for later. It's always good to just take out information that you might need for later. If you end up needing it, then you're thankful you did it. If you end up not needing it, whatever. You have more than you needed. You feel smart. So the question for example 1 is, write this quadratic function in standard form. Standard form. That's the ax squared plus bx plus c. So how do we get that? Well, first off, we do the parentheses. We do the exponents first. So we're going to do x minus 2 times x minus 2, like this. X times x is x squared. X times negative 2 is negative 2x. This is also negative 2x. And this is positive 4. So now we've got, move this back up here, x squared minus 4x plus 4 in parentheses with a 2 in front of it and a plus 3 after it. All right, I'm going to erase this. Now, next I'm going to distribute this 2 into the parentheses. So 2x squared minus 8x, because that's 2 times negative 4. 2 times 4 is 8, and then plus 3. And then finally, move this all down. 8 plus 3 is 11. And that is the standard form. Example number 2. F of x equals x plus 3 times x minus 2. And then want us to write that in standard form. So all we have to do is distribute, do FOIL. We have to do FOIL. X times x is x squared. X times negative 2 is minus 2x plus 3x minus 6. Add these together. 3x minus 2x gives me x. X squared plus x minus 6. Standard form. Easy peasy, lemon squeezy. I'll just move right on. No need to pause. Write this function. F of x equals x squared plus 2x minus 15. All right. Write this in factored form. So that's where we come into that one lesson where we took trinomials and broke them down into 2 binomials. So let's see. 2 numbers. We don't have, there's nothing in front, so we don't have to worry about that front thing. 2 numbers that multiply together to be negative 15. So that's either 1 and 15 or 3 and 5. And then they add together to be positive 2. So that, let's say it's negative 3. No. Yes. Negative 3 and positive 5 would be 5 minus 3 would be positive 2. So we're going to go x minus 3, x plus 5, and then it's always a good idea to check. So x squared plus 5x minus 3x minus 15. And it looks like we're good, because that 5x minus 3x gives me 2x. Example number 6, determine the vertex of this equation right here. Y equals negative 4x squared plus 8x minus 1. Okay. It's not a very good 8. Slightly better. There's a special formula. X equals negative b over 2a. And that will tell us the x-coordinate of the vertex when it's in this form. Only when it's in this form. If it's in the ax plus bx, or ax squared plus bx plus c, if it's in that form, this equation will tell us the x-coordinate, that's a lot of information, the x-coordinate of the vertex, right? Okay, so negative b is, this is b, so that's negative 8 over 2 times negative 4. 2 times negative 4 is negative 8, so that's negative 8 over negative 8, which is equal to 1. So now we know that in the vertex of the 2 points, there's an x and there's a y. we know that the x is 1. How do we find the y? Well, we take that 1, we plug it back into these right here. So let's see here. Negative 4x squared. X, if x is 1, 1 squared is 1. 1 times negative 4 is negative 4. Plus 8, because 8 times 1 is 1, and then minus 1. So 8 minus 4 is 4. 4 minus 1 is 3. So 1 comma 3 is our answer. I got fairly complicated. Maybe rewind and see again now that you know where we end up. Rewind and watch again. And maybe it'll make more sense. All right, last bit for this lesson is whether a graph is even, odd, or neither. These are aspects of a graph, ways to describe a graph that have certain relationships with the y-axis. So there's a way to solve this algebraically, where you look at, like, if they give you just the numbers, like for instance, this example is f of x equals x to the 5th minus 2x cubed plus 6. So they give you this and just tell you to solve, or not solve, but tell you to determine whether it's even, odd, or neither. And there's a way to input negative x and work this out that I don't quite get. So I don't get it well enough to be able to teach it to you. I'm sorry. But there is a way to figure it out by graphing. So basically, if you just do the table of points where you put in from negative 3 to positive 3 for x, negative 3 for x, negative 2, negative 1, 0, 1, 2. Just do that and see what it produces. Graph it out real quick. If it has symmetry on the y-axis, right, where it's identical on the left and right, if it has symmetry on the y-axis, it's even. That's symmetry. Symmetry is even. Okay? If, on the other hand, it does something like this, then it's got what's called rotational symmetry. Meaning if you take this line and rotate it around, it would mirror that line, but only by rotating. See that rotation there? See what I'm doing? That's rotating around the origin. If it can do that, if it can rotate, it's odd. If it does anything else, it's neither. So most of the graphs are probably neither, except when they're asking about this, because then they're going to bring up specifically a graph that does one or the other, and your chances of it being neither are pretty low. But like, for instance, this is a pretty normal graph right here, but it has neither because it doesn't interact with the y-axis. Same one for this one. It's a wonky graph. It's not a proper parabola, but it doesn't interact with the y-axis at all, so it's neither. Okay, so that's the end of this lesson. That's the weirdest part. And frankly, if you don't get it, it's only like 1 or 2 questions on the test, so maybe it's not that big a deal.